Well, we could. Hey guys. Yeah. So welcome to. I don't know. This is the at the end of the first half. Um, because next week, um, yeah, let's not even introduce objects next week. Well, maybe we'll we'll touch upon it. But next week is the second half. But it's because it's the midterm. Let's just use next week for review, right? So basically, let's do Tuesday class and any topic we've covered so far. Okay, so anybody who wants to talk about it themselves or me or ask their classmate and have a group discussion, let's do that the entire Tuesday, right? Also Thursday, I mean, because you don't have to take the midterm in the morning. You can take the midterm after class, so you can use the Tuesday and Thursday class to have a group discussion and clarify questions and concepts. And then take the test in the afternoon, right? Oh, I got to go to what is that view? Gallery view, right? So I can't see all of you. Now, well, I can see, I think, all of you. All right, yeah, well, it's only 8:02. We'll give people a chance to join us. And today, let's do some more live coding. And actually, I did mention that idea, and I was thinking more about it today, and I think it's like a really cool idea to implement, right? Coming up with sentences, because eventually you're going to, I suppose, implement some kind of a game or something that is interesting and meaningful, and you want to have a source. And a source, an AI source, maybe, right? So you could tap into an AI source. There's so many of those, right? That will generate sentences for you in a domain that sound realistic. But especially if actually, hands up if any of you are interested in this field of natural language processing, right? Human language processing, which is an essential part of AI, right? Because if an AI system needs to communicate with us, do interesting things and communicate with us, it needs to it needs to be good at NLP, right? It needs to be able to understand gestures and even what we see as part of a language, a visual language, or anything that's communicable. And so the system has got to be good at natural language communication. And obviously, we use a grammar for communicating, right? If it's completely free form, like I said before, right? Freedom by itself does no good at all, because it's unconstrained and you don't know where to go. You're free, but you don't know where to go. Right? So I say, okay, well, now at last, I'm not bound by any of these rules out there. I'm totally free to do whatever I want, right? So that's the first step, to be able to be free. But being free by itself doesn't buy you much, right? So you need a couple more things to be there. And one of these things is the structure that these rules provide. So you can improvise within the rules. And because these rules are tried and trusted by many generations of intelligent people, right? Because they've tried things, and if things don't work out, right, even in corner cases, if things don't work out, those techniques are not going to survive amongst a series of intelligent generations, right? So what we see, if you look at what all these rules we have in place and look at them as not really restraining us, but really these rules are the result of independent free thinkers, right? Not constrained thinkers, because constrained thinkers cannot discover rules, right? So these are rules discovered by independent free thinkers over centuries, right? So we can't limit ourselves to, I only look at, what's been intelligently created in the last 15 years or 20 years, 100 years. Well, that we're so much poorer, right? But if you extend the lifespan of intelligent humanity, right, as far as intelligence allows you to, right, you'll see that many of these rules that we have in place have actually evolved through the human spirit, trying to chart ways to find what fulfills us, what makes us happy, right? Any art form and these things. So that's why we try and improvise within those guidelines. And even that we can't exhaust, right? We say the ultimate point of freedom is to be able to improvise, right? Try new things, right? And we say, okay, well, here are some rules by which you can play this game called baseball or something like that, right? So you can improvise within that. And even then we find we can't run the full gamut of our freedom, because even within those rules, there's so much we can do, right? We never exhaust what is available. So I think that's the whole idea. I don't know how we got started talking about it, well, but basically we're just waiting for other people to join us. Hey, I emailed a couple of you who were not speaking to me last class when you have your window up, like Isaiah, right? Isaiah and Maxim, two people I remember, right? From last class.
Yeah.
You guys were there. Isaiah, your photo wasn't there. Your name was up there, and I spoke to you a couple of times. Look at the video, right? And you didn't reply. And well, a couple of times, maybe one time you stepped up, right? But you got to be. And also, if I send email, please reply, guys, because that's the only way I can make sure that everybody is in step. Okay, I don't want one guy marching off all the way and a lot of people are behind. Then I have to be running back and forth, right? I got to be with one group. So you can help me by all staying together. So that I don't have to. All right. So please be interactive and together as a group, right? We have to. Otherwise, it's no fun at all. All right. Well, I think I've done my bit to keep the airwaves occupied for 7 minutes. So I don't want the silence to reign. Okay. Also, you guys should decide who's going to go today. Hey, actually, you know what? Wait. Who's here? All right, Jacqueline and Yenyu are the only two people I can see today who haven't had a chance. How are you on? You coded on screen. I can hear you.
Yeah.
You
Yeah. I already went. Yeah.
Yeah, so that's what I mean. So the only two people I see on screen today that haven't coded on screen who want to have you should take this opportunity. It's absolutely fantastic, I think. And we'll do this thing, we'll generate a sentence using it looks like AI, but it's not going to be AI, because I think what we'll do is there's something called a slot-based grammar. Right, a slot, and it's very simple. In fact, this is a great opportunity for me to use my iPad in the mode that I originally wanted to use it. Right, to use it as a whiteboard and draw with my pen. And I bought it and I never used it. All the time I've been using it to film Peter. Right, who just stops by whenever he wants. Right, when my iPad is run out of battery. So. But I'll do that, right? I'll describe what a slot-based grammar is. It's so simple, right? It's so simple. And once you get used to slot-based grammar, you'll actually see that it's very similar to many visual scripting languages out there today, right? So later on, maybe you say, oh, I'm going to go and learn Unreal Engine or something like that. Right now, Apple introduces some, AR programming framework, right? And they're all going to have visual scripting in there somewhere, right? So you go and look at it and you'll say, hey, it's very similar to what I did. It's slot-based grammar in CS2A a long time ago, boxes and lines connecting these things and choices to make at each point, right? It's basically your C++ program translated into pictures, basically a flowchart, right? And many of these visual scripting languages are basically flowcharts, allowing you to encapsulate complex logic in boxes, and you can connect them, and that's all it is, right? So, that's why I think that, if you're a good C++ programmer, you can be a good visual scripter also. Right, you don't. So once you get to a solid level of comfort with C++, you don't have to code another word of C++, right? Or any token-based programming language, or any lexical token-based programming language, right? You can now go on to visual scripting. And in certain places you'll be compelled, I suppose, to write in a particular language, but mostly you can, because I think that getting the feel for programming is important, right? Not whether you do it with visual scripting or C++. Getting the feel is important. And once you get it, you can, because there are lots of people who absolutely don't have a feel for programming, but they just do visual scripting, and the programs will be equally on par with someone who's basically self-taught themselves programming, right? But not really followed good practices all along and cuts corners, and therefore gets used to cutting corners. Gets used to cutting corners, and well, why do you cut corners, right? When you cut a corner, you're essentially making a compromise, right? You're saying, I don't want the best in life, right? I'm going to cut a corner and take what's available to me, right? So every corner you cut is a compromise, and most people will start feeling comfortable with cutting corners, and you'll make lots of compromises. And so you say, you know what, the best way to get the most out of something is not to make a compromise. I'll just keep going. And once I get comfortable with not making a compromise, right? Because we're not comfortable with not making a compromise. That's why you always, the only way to solve this is because I'm going to get so many infinite number of situations as long as I live where I have to make these compromises. right? So if I'm never comfortable with making a compromise, I'm going to be uncomfortable for the rest of my life. So how do I get around this issue? So the only way is to just sit down and at least mentally simulate this whole damn thing, right? And say, suppose I don't ever make a compromise, right? So where's that going to lead me? And it's going to get more and more comfortable. Uncomfortable, right? So, and you say, okay, well, let me bear with that. And you go all the way to the end. At some point, you'll say, well, I'm not going to be, but so I'm not going to be uncomfortable with making compromise anymore, right? So, or yeah, or something, right? So not making a compromise. So you keep going, and it's that I think that is a way to basically simulate things, you know. Because at the end of the, I'm just keeping the airways occupied, right? So I think we'll start in about 5 minutes. And obviously anybody can interject at any time, right? Because I think at the end of the day, I think maybe an alien civilization, right? An alien race from a different planet who we haven't been able to observe so far, comes forward and hugely powerful. We can't do anything about it. But the thing is, they cannot see, they cannot feel. Right, like right, they can feel like humans, right? They can feel like themselves, so they're kind to each other and everything, but they just can't feel like humans. So as far as they're concerned, humans are like grains of rice, right, that they can harvest, or they can do whatever they want, right? And all kinds of any painful experiment they feel is worthy to do, they will do on humans. There's nothing to stop them. They'll be kind to each other, right? And so that's because they're not able to simulate the feeling they have in another species or another race, right? So and so what is it that prevents us from, because we don't even have to go to another, because how do humans torment each other, right? So over history, even now, this is all these people. How can a person get to a stage where they can actually see the other a person as not having any feelings whatsoever, right? So not able to see themselves in that other person. How, right? So the only way is to see them as an automaton or a being that is responding to stimuli, right? And so there are humans like that. So why, and routinely people, we look at animals and other things and refuse to inject our own selves into that other creature and refuse to feel what we would have felt if we were in that situation, however constrained it might be, but it's an unpleasant situation, right? So and so it's possible that, and so what is that thing that prevents us from simulating what we would feel in the other person's shoes? Because most of the time we just get by in an illusory world in which we have imbued all these other characters that we see in our life with feelings that we think we would feel if we were in their shoes, right? Because we have no idea what they feel, right? We just say that if there were a million copies of me and they were all in these, that's what we'd feel, right? So and we imbue these characters with those feelings, but most of it is not right, obviously, right? I suppose we could prove it, right? But it's not right. It's just what we think it is. That's in Hinduism, that's what we call Maya. It's a completely different world, right? Each person is living in a completely different mental world where each character has different motives, different everything, right? So everything is self-centered. It's different. And what is it that prevents us from piercing that veil and looking at the other person truly as they feel towards you? Right? So we're all accustomed to seeing love everywhere, right? So you could say that is true love, where you actually feel what that other person feels towards you, not what you feel towards them, right? So maybe that's possible. So here it is, right? It's a wild ass theory, and suppose a science, someone proposes that. How would you test that, empirically and scientifically, right? So that's the whole root of the issue. And so what is it that prevents that us from peering through that and feeling? It's because we are afraid, right? We are afraid of the truth. Like Jack Nicholson says in the film, many times we can't handle it. Many times we cannot handle knowing what that other person actually felt. Maybe we went out and sold that person, even though that person really truly loved us. Maybe that was the only person who truly loved us in our whole life, right? And we didn't know that, and we just bowed to society. And because of societal demands and all these other things and what people say is holy and good, we actually incriminated the person and subjected them to a horrible death, right? And we never knew that because we refused to project ourselves in that person, and we never knew what they felt. And all of a sudden we came to know the truth, right? How would you ever live with yourself after that, right? So that's, damned if you do, damned if you don't, right? Because if you continue to live on, you can't live until you know the truth, right? It's going to nibble away of you. So you can't live until you know the truth. But if you know the truth, you can't live with yourself, right? So there are lots of things that we just consciously block away. And that's the only way in which we can construct a world which is, halfway acceptable to us. So, and so we're lost in that. And I think that there is a way. So suppose someone comes and says, well, you know what, there is actually a way to pierce through that veil and do a complete simulation, right? Suppose someone says, here, I have a theory that every human brain or every human person actually has the ability to do the complete simulation. Right now, we're just doing unidirectional simulation, right? We're just doing, what is it going to be like, if I'm in that, right? So everything like that, it's a half-assed simulation, really, right? It is just enough to get by in the world and live, right? But it's not a complete simulation, and we accept that. But suppose someone says, no, actually, you know what? We've run our latest simulations. There is some quantum stuff going on in the human brain or something like that, right? So, and it is testable empirically, that a human brain is actually capable of running a complete simulation that is bidirectional, right? Which is basically, whether even that is possible, right? It is an infinite loop and all those things, but maybe there is a mathematical framework in it in which all of that makes sense and it's possible, right? So maybe it's testable. And the question is now whether we would still accept to do that, right? What the hell was I saying, right? So to say that, okay, well, there's the switch that we can turn on to actually run the complete simulation from both sides. Can you see? And that's what I see, right? So there is a truth, and we can't. And we can many times people can't, and that is the reason why we don't. And I think that as we get better and better, more and more intelligent, we improve in our ability to be able to simulate things bidirectionally, right? So maybe we start off only with unidirectional simulation, and slowly we gain the ability as to be able to simulate the other way too, right? And we start with animals and little things, and slowly with humans, right? So but I don't know. I'm just rattling off. I got to edit the first 20 minutes, right, of the video. We haven't even started class. Nobody is talking, really. You guys should just feel free to interrupt me at any time. Like I said last class, silence is very infectious, right? I mean, I could just say, like last class, that's what I did last class, right? And I said, I'm going to switch off, right? I'm going to go off screen. I'm going to switch off, and then I took off. And you guys were talking. Right, and so I decided to do something, and then all of a sudden there's silence and nobody's talking anymore, and so yeah, so someone has got to be talking about anything, right? It has to be, it can be. So that's what they say, right? Well, what do you do in English classes, right? So when you have to write an essay, what I don't know. This is many of the English teachers I know, that's what they recommend, right? So they just say, write any damn thing you want, right? So it doesn't have to be grammatical. It could be total nonsense, anything that comes into your mind, right? Like now, right? I'm just talking, right? I'm just talking total nonsense, and most of what I say maybe has a 50% chance of being right or wrong. Right? Who knows? Right? So I don't care, because I just toss it out there, and it's up to you to look at it and say, hey, Anand said all that nonsense during class today. How much of it is actually, sensible, right? Makes sense. So those are things that you can take care of. And that's the reason I'm just, talking and talking, really, because, I'm scared that if I take away, then again, you guys will basically just not talk to each other, or, silence. Hey, Jacqueline's here. Where's Yenyu? Yenyu. Okay. All right. You guys don't take off. Okay. So you're going to code today. Yeah. Is that okay? Okay. Yeah. Okay. Good. All right.
Would you say that branching statements are cutting corners?
So I'm sorry, cutting corners? No, actually, you'll find out. Branching statement is not, right now it looks like branching statements is cutting corners because it's got this, fork and all. That's not what I mean. But later on, when you have to do loops and conditions and intricate beadwork with your programs, you'll find that there are some tasks that you can fail to do, right? And still your program will work 99.9% of the time. So what will happen is that you write your tests, your loops and everything, your program, actually it'll seem to work, right? Most of the time it'll work, but in certain corner cases, there actually, we talked about a corner case a couple of classes ago. I think Chanyi, where's Chanyi? Oh yeah, okay. So user experience corner case with the Price is Right. Price is Right. Yeah, Price is Right, and there was a corner case where two users have the same price. Yeah. So yeah, that's what I mean by a corner case. The corner case is something that happens once in a while, not often, and so programmers are unfortunately victim to many corner cases in their programs. Not victims. They have to be aware because what happens is that there's a program. It works. It works here, but it works. It doesn't work in a small space. Another program, another part of your program doesn't work here. So maybe you have a part of your program that works 99% of the time. This is 1% of the time it doesn't work. Okay, so maybe 1% of the users doesn't work. Maybe you have another case like that in your program that also works 99% of the time. But the two and together, then it's 0.99 times 0.99, right? So it can only get smaller and smaller. So the more corner cases you have that you cut in your program, the less likely it is to basically be a robust program. It's likely to fall apart at any time. That's what I mean by a corner case. In fact, we have a Quest.
It's just that I've seen a lot of demonstrations that suggest that branching statements slow your program down, because in the compiler it has to pre-calculate both ends of the branch, right?
No. Why do you say that? I mean, what does it mean by saying a branching statement slows your program down?
Well,
how would you make a decision at all if you don't have branching statements?
I think where this usually comes into play is when you have the opportunity to not use a branching statement, especially when it's a mathematical comparison.
Oh, I see. I see. All right. Okay. So you're talking about some, that's a corner case. Yeah, I agree. It's a corner case in that sometimes, very rarely, you can take the result of a mathematical expression and assign it to a variable, which the same expression can be calculated through a branching statement also. Yeah. But I wouldn't even worry about these things, right? They're so extremely rare. And I don't even think that these kinds of operations are within expensive loops that are actually used in production. Or if they are, programmers, we're intelligent people, right? We'll figure out, right? In that particular case, instead of using a switch statement to determine the value, I can just plug in the gamma function, right? Yeah, take the factorial, right? Factorial. Factorial, you can actually loop with a corner case and everything, condition, and then calculate the factorial and give it. Right? In many cases, you say, I don't need the exact factorial. I just need the gamma function value, because the gamma function approximates the factorial curve, right? Well, I'm drawing it the logarithmic way, but but I'm talking about the factorial, right? So okay. So you can actually calculate a mathematical function instead of calculating a looping thing. Although calculating a mathematical function involves various floating point algorithms to be executed. Right, and inside of those floating point algorithms, you're invariably going to have some kind of looping structure, right? So I don't think it's possible to have anything realistic that does not have any looping, right? Even if it's something as simple as printing "Hello World," right? Because there's so many. Even if it's a program that does nothing at all, right? Because just the fact the operating system loads the program, there's so many intricacies that are already built into your program by the compiler. It's impossible to eschew branching statements altogether. But yeah, I don't know. It doesn't make sense. Well, it does make sense in a very, very slim corner case that you can use. In fact, I'd be interested if or any of you can think of mathematical functions that approximate, branching statements, the output of a branching statement. Yeah, yeah, exactly. Yeah, very simple. We got a case, right? So determining if a number is even or odd. Yeah, so you can actually just do it with a mathematical modulo operator, right? If %2 equals 0, again, you got a branch. Oh, no, you can basically, that's a Boolean. You can assign it to a, I don't know. Let's not get into that, because yeah, I'm sure if there's one, there's going to be many like that, right? So I'm pretty sure there are, but I wouldn't worry too much about that. Yes, but thank you for bringing that up. Anything else? I'm happy to, yeah,
was
I'm happy to
kind of making a joke, but I was thinking that the thing that you're talking about after cutting corners is kind of like the point of view gun from the Hitchhiker's Guide.
you know what? I think I mentioned this before. I also quote from the Hitchhiker's Guide many times, but I'm one of those strange people who don't read entire books, right? And so there's all these interesting parts that people like you tell me. And then I just go and pick up the book and read it, and that part, and then I get distracted after a while. But I remember that, right? So that's how I remember that 42 story and all those, the deep thought thing. But you know, obviously, what is this thing about?
It's like this hypothetical gun that, according to lore, I believe was invented by women so that men would finally understand, you know, their point of view. And when you shoot someone with this point of view gun, they just have your point of view.
Oh, I see. So you get the other perspective, flip around. Hey, that's cool. Yeah, that is cool. Yeah, it basically ties in exactly to what we were talking about, I think. Yeah,
Yeah, it's just
yeah, exactly that.
an idea, right?
Yeah, exactly. You know, I used to be. It's interesting that, you know, if anything we say, if what we say is true, then obviously we didn't come up with it, right? It's been around forever because, you know, we didn't just invent it. It's been there forever. If it's not true, then, well, you know, what's the point? We don't want that to be associated with us. So it's kind of funny. Yeah, so any cool idea we come up, any fantastic algorithm, scientific theory, if it's the right theory, you know, I mean, intelligent people have found it before, I think, right? Maybe I've maybe lost. Even calculus, right? You take calculus, even at the very same time, multiple mathematicians came up with calculus, right? You know, Newton and Leibniz are fighting with each other. Yeah, you know, it's science. There's, you know, politics creeps into science too, and it's kind of nasty when that happens. Anyway, you guys should feel free. Yeah, well, when can we start? Like in 5 minutes? You know, Jacqueline can pick up the screen, or, you know, I'll get the iPad going, and get a whiteboard, and hey, Jacqueline, are you going to be using an IDE or this online environment? Either way is fine.
VS Code.
Yeah, VS Code. Okay, cool. All right. I gotta start Canvas here. Join the meeting. You know, you guys should just feel free to talk, whatever you want, right? I mean, it's not like, until we start getting into this project, it's not like, you know, okay, no audio. Share content. Whiteboard, yeah. Great. Oh, that's right. Okay. Oh yeah. Oh boy, Jacqueline's ready already. Okay, cool. It's really bright. That's much better. All right. Yeah. Okay. So generating sentences, and it looked like AI, but it's actually what is called a slot grammar. And a slot grammar is essentially, we want to generate sentences, right? So we basically draw it out like here. Can you guys see my white? Is this my whiteboard? Do I need to? Oh yeah, it's mine. It is mine. Okay. All right. Okay. Yeah, a slot grammar essentially is, you know, let's say we want a sentence, and we say a sentence like, you know, let's take a very simple sentence. You know, the one that I pick every single time, I think, when I talk about grammars is, you know, the cat's out on the mat, and let's say the cat sat on the mat. Right. There's, two ways in which we divide this thing. In the previously, if you think about it, we said this is the subject. This thing is the subject, right? And this is the predicate, right? So, yeah, do you remember we talked about this, and we said a predicate has always got a truth value. It's either true or false. Side of the mat can be either true or false, and that's why our Boolean variables, if they're good to be named as predicates. There's another way to group this, and this is called a, right, and we're going to say a sentence is basically a noun phrase, right? This is a noun phrase, right? And I guess you'll learn these in English, right? And this is called a verb phrase, and we'll call this a VP, and we'll call this a noun NP. Okay, so let's say then I'll just call it an NP. Right? So what we want to do, and already I think you guys are starting to get the idea of what we're going to do in the program, is basically we're going to tell in our main, we're going to say, all right, give me a random noun phrase, give me a random verb phrase, okay, random. And we'll see how we can use sran and ran and pick these words at random, okay, verb phrase. And then we're going to stitch these two together, right? As O stream or whatever it is. And we're going to say my sentence is actually a noun phrase, a random noun phrase, and a random verb phrase, them together, right? And however, how do you get a noun phrase? And how do you get a noun phrase? Again, we're just going to do everything recursively, just not recursively. We're going to think about everything in the same way, okay? So in order to get a noun phrase, all we're going to do is, here we got a cat, the cat, right? Let's actually make it more interesting. Let's say the angry cat, right? And then while we're doing this, maybe someone can also look up the net and find some interesting sentences like this, right? So maybe in Star Wars quotes, because what we want is eventually, when we get down to the slots that we need to fill, and we say, well, we need a noun now. And then we'll say, give me a list of all interesting nouns and pick one randomly from that. Right? So maybe you have Jabba the Hutt as a noun, or a dog, the cat, right? Maybe even, people in there, anything, right? So things, and we put a lot of nouns in there, and then likewise we pick a random one, right? And then we string them all together, and we get a random sentence, right? And that's going to be our 8-ball kind of thing. So we can, someone can come and play this random game, and they get a random sentence. Okay, so the angry cat, let's say, sat on the actually, let's this is called an adjective. This is, I don't know, right? This is called an article. Okay, and this you can say it's a noun. Okay, and then this entire thing is a verb phrase. However, we'll say this is your verb. In the verb phrase, this is going to be your verb. Now, anything here that is confusing to you, you should basically, oh, it's the angry cat. Let's actually stick something in there called an adverb. The angry cat, let's say, sleepily sat, or or give me a good adverb here, guys. How do you sit, right? Simply sat. Okay, well, I'm just going to say simply for now, right? So instead of sat on there, I'm going to say simply sat on that. Right. Hey. Okay. Hey, this is not working. Huh? My pencil failed to connect. No, it's oh, that's funny. Give me 1 sec. Okay, this is not working. Maybe change color. Oh, there. Okay, all right. So instead of verb, we'll say it is what was the adverb we use, and each one of these we can just pick random ones, okay? And we'll see how interesting our sentences turn out to be. Give me a good adverb. Is it going to be simply? Broodingly, because it's angry, it's got to be brooding. Okay, broodingly sat, right? Well, let's not even make it sat. Broodingly, yeah, well, okay, let's just sat. Let's not waste time, right? That's your verb, and On is going to be what is called a preposition. We'll call it PP, right? And then let's say this has got to be another noun phrase, because that's actually a noun, isn't it? Because the angry cat broodingly sat on this is, I think, again, an article, right? I don't know how our sentences are going to work eventually. On the blue mat, right? Let's say blue mat. Okay, long sentences. Okay, blue, that's going to be an adjective, right? And then mat is going to be noun, right? Okay, all right. So what we've got here is basically we got to generate a random random article, and then generate a random adjective, generate a random noun, right? Generate a random adverb, a random verb, and so on. Okay, each one of these is going to be a random one. And how are we going to store these things? We're basically just going to store them as arrays, right? So we're going to have an array of vector, right? We're not worried about arrays because arrays, you have to find the end and all. So we'll say they're vectors. So we're just going to have vectors of articles and adjectives and nouns and adverbs and so on, and just going to pick these guys randomly and string them together, and that's basically it. So in this little program, I think we would be able to exploit, get to play with arrays, vectors, and loops, and functions, and getting function return values and putting them together into something that is mildly interesting. How about that? Is that okay? Yeah.
Yeah.
Okay. All right. So let's see. All right. How come it's still sharing even though I switched off my iPad? It's funny. I switched off my iPad and still sharing the whiteboard.
Yeah, I think you have to
Yeah.
manually do the unshare or stop sharing.
But let me actually quit Zoom on my iPad, okay? Because if I quit Zoom, obviously it should.
It's still there.
So maybe I have to quit Zoom the other way. Maybe it just went to sleep. Hang on. Maybe it's there. Okay. Yeah, that's right. So I'm gonna quit it the other way, which is to get it. Oops. Damn. Hang on. So oops. There you go. Oh, geez. Okay. Yeah, I got to get the hang of doing this. Okay, so this is the one. Okay, this is the one. Okay. Just getting rid of this thing is okay. This is gone.
If nothing else works, we can cut a corner here and have your administrative privilege just like disable your iPad, can't you?
Yeah, so I managed to quit it, but I think I got to figure out how to do that thing. In the iPad, it's possible to quit a single app, right? Completely quit, basically get it into the task thing and eject it. But getting into that, I haven't mastered the gesture. But fortunately, I received a phone call, and the phone call killed the Zoom app. So that was really cool. So there's well, hey, I'm going to take this call, okay? I'll put you on mute and for a sec.
So it seems like we're working what is effectively a randomly generated MATLAB with a word bank.
Yes.
So is there a way we can use the same library, like for an example, take an input from the user as a text and turn it to an integer or something?
Yeah, I think just for testing though, I would stick with, RNG and then let that pick all the parts.
Can I ask a totally unrelated question?
Yeah, go ahead, man.
When you guys complete the quests, are you getting grades on your canvas, or it doesn't pop up?
You're supposed to check some other
Only
website.
if I put my student ID in that first section after the word student ID. So on my testing where I don't have my student ID, that way if, it like breaks, I'm not concerned, oh no, I used up too many submissions and now I don't get a grade.
I'm just kind of like, I don't know where to check, like, because I've done up to 4, but I don't know, like, I'm getting like the initial number, but I'm not sure. It's because it's not popping up on Canvas. I don't know where I'm supposed to see it.
Yeah, here,
So
let me
check
get
the
you a
website I
link.
just shared.
Oh,
Oh yeah, it's on the in the chat.
Yeah,
Clutch.
that Chen also. Okay, now you've got 3 links to it in chat.
thanks, guys. Oh, perfect. Nice. All right, cool.
Great. Okay. Yeah, I'm back, and Jacqueline can take the screen, and then we can start coding. Yeah, that's great. We can start coding. Let me try and think of how we can put this together. So we'll start with the main, and in the main, we can say, what was the template we came up with? I forgot the. So yeah, I think the angry cat broodingly sat on the blue mat. Yeah, okay. So we'll write that in comments at the very top, and then that's what we'll try and model. And then in the program functions, I'm pretty sure that we'll have to make some intelligent decisions, right? Because sometimes when we pick a noun that follows an article, so we got to choose between, we got to choose the article based on the noun, or choose the noun based on the article, right? We can't say the or an. You got to say an apple, right? You can't say a apple, right? So you got to choose the noun apple based on, oh, I picked A, so give me a noun that begins with, that doesn't begin with a vowel. Or you could say, give me an article for this noun. Normally we pick the article based on the noun. Yeah, maybe we can do that, right? Maybe we can do that. Well, maybe we can pick the article based on the noun. I think that would be really cool. So yeah, lots of scope for cool and interesting things that we can do in this class. Yeah. Okay. So the angry cat became. No. I think it was more complex than that. The sentence was more complex. The angry cat sat on the broodingly sat. Yeah, broodingly sat. The angry cat broodingly sat. Yeah, get rid of the became. Hit delete. Yeah, broodingly sat. Sat on the blue mat. On the blue mat, right? So, and you can tag that as an example, right? Example, and right at the very top, you want to say the comment for the whole program at the very top, the very first line is that this program is for generating a random sentence like the following. Increase the brightness. Okay, that's better. Yeah, okay. So you can get rid of the pick article based on noun and so on. And then you can say on the next line, after the example, you can say template colon. Yeah, say no, after the example, you can start another comment just to say that's a template we're trying to follow, right? So after start another comment right there. Yeah, okay. And then line up and template with example. Yeah, colon. Yeah, colon. Yeah, that's fine. What you have is fine. What you had is fine, right? Template. And then you say article, ART. No, art, just all uppercase. Let's say all uppercase. ART, space, and then what's the next one? Angry is adjective. ADJ, and then noun. Let's say N. Yeah, and yeah, N for noun. That's fine. And then broodingly is an adverb. So you say ADV. And then sat, you can say V for verb, yeah. Because nouns and verbs are common, I guess. And then for preposition, you can say PP or P or something like that. Oh, and then you still have the blue mat. So you need article, article and a noun and adjective and noun. Article, adjective, noun. ADJ, noun. No, and you're using man, right? So that's the order in which we have to pick these random guys to get these random things, right? So you can get rid of the blank line between example and template. So meaning that that's the template is very, is derived from that example. Essentially, that's basically what we're trying to fill, right? And and you can say the idea is that, and another comment is the basic idea is to pick a random one of each one of those above categories. Basic idea is, yeah, pick a random, one from each of those each of the above categories. Is everybody okay with this so far? Yeah.
Yeah.
Yeah, so that's all. In fact, when you get to a later quest, you'll actually see in your quest, you'll see lots of random sentences used in the quest data, right? And that's how these random sentences are generated, right? So I use something like this, very similar, to come up with my random sentences. And so basically, you're doing a part of what I do in questing, essentially, right? On the other side of questing. All right, so a basic idea. All right, now, yeah, and then you do the standard stuff like hash include IO stream and let's use namespace standard, so it'll save us a lot of typing. So yeah, hash include IO stream and using namespace standard. All right, IO stream has got to be within angle brackets. Yeah. What else do we need? Yeah, we're going to use vector. So might as well use vector also, right? On the next line, you can say hash include vector. And I'm pretty sure we're going to use stream. Yeah, we'll use stream. So you say hash include stream also. Stream is where we actually use string stream and format things and so on. So we're going to have to use this at some point, hash include stream. And we'll leave file out of this, right? So let's not do file messing around with files. All right. Okay, and then a blank line, and then using namespace standard after. No, you can do the blank line after a stream. Yeah, blank line, and then using namespace standard. Using namespace standard. Yeah, we got a lot of time. It's only 8:50. We got a whole hour, and you know, a semicolon after using namespace standard. Yeah, okay, yeah. So int main, we'll do the main, and then after that we can string up the rest of the things. So main has got to have these. Yeah, that's right. No, where you have the cursor or the mouse. No, the parentheses needs to go. After the main. Yeah. Okay. And then you can have a space there. It's better to have the space on this side of the parentheses than the other, because the parentheses associates with the main rather than the body. Yeah. Okay. All right. Cool. Now inside of main, all we want to do is get random stuff, right? So the first thing we want to do is srand. Okay. Let's not get bitten by the random bug again. So let's just call srand right at the top. Say srand, and then pass it the value of time. And again, let's just do the proper thing and cast it, right? Say unsigned within parentheses, right? Before calling time. No, not less than srand is a function call, so you need a parentheses. No, not even is a variable. It's a function call. Yeah. So inside you say within parentheses you say unsigned, meaning whatever the function whatever the quantity is, make that unsigned before passing it to srand. That's what we're saying. Okay. Space. And then you're going to call a function, get the return value of the function, and give it to srand. The function we're going to call is time. Time is going to read the clock and give us the seconds, right? So time, no, not equals. You just say time. So you just say time, and then within parentheses, you say 0 uppercase L, right? It really, the L doesn't matter anymore, but it's just historical baggage, I guess. All right, so you can close the parentheses right there. I think is that it? No, I think it. Oh no, unsigned. It's missing. Before the unsigned, you need one more. Unsigned is a typecast, right? Yeah, one more left parent. One more there. Yeah, I think shift 9. Hit shift 9.
Sorry, what do you mean?
Hit one more left parentheses right there. Shift 9. Right there. Where your mouse, where your cursor is right now, hit one more parentheses. Not there. No, you move the cursor now. So before the unsigned, move. No, not there. Right. So go before the U. Go before the U. Right there. That's where your cursor was, I think. I don't know. I might have been. Yeah. There you go. Okay. So unsigned is in it by itself. Is something we want to typecast the return to, right? So that's a syntax, right? But forget about this line. Let's not belabor this line, okay? I think we just copy and paste this line into all of our programs without really understanding. Well, it'll come to us eventually, right? So yeah, semicolon, and after the semicolon, hit enter. So now all we want to do is and then enter blank line, and then here all we're going to do is pick random components and string them together. So put a comment there saying in a comment you just say pick random components and string them together. That's it, right? And then components and string them together. Yeah. Okay. Now all I to make, and then you can copy and paste that line 4. Everything uppercase in line 4. On line 4, copy that. Yeah, copy that. Yeah, copy that and say in comments. You say in comments. Yeah, to the beginning of the line in comments. You can say to make our. Yeah, great, thanks. That's fantastic. All right, that's all we want to do. So, so you can actually say at this point, say string article 1, right? String article 1, because we have multiple articles here, right? Yeah, I think we have multiple articles. Yeah, we can look at ways in which we can simplify this and streamline this program much better, right? String string. Yeah, art1 equals equals. And you can say get underscore random underscore article. Yeah, that's a function. We're going to call this function. Yeah. So we're going to pass. Yeah, semicolon. Enter. Yeah. Now we're going to say what is it? String adjective, right? String adjective. String is adjective 1, right? So we have multiple adjectives, right? So you say adjective 1 equals. And you can copy and paste and even change if you want, right? And random adjective. And then we'll try and before we do any of this, right? We'll try and make this more better that we'll try and parameterize these things, right? We're going to parameterize these functions so that the article we select depends on what comes before it or what comes after it. So we can do all those really cool things too. Yeah. So yeah, and N1 is it? Yeah, and N1. Yeah, so you can flesh the other ones out. And then after that, all we need to do is just print, right? We just need to print, see out all these guys with a space between and a new line at the end. And you can say your random sentence of the day is bam, like that. That's it. And after, and then we do one of those functions, immediately how to do the rest of the functions too, right? We just need to pick some interesting words from the net and flesh out our adjectives and nouns and so on and so forth, right? What are we going to do for the rest of the day today? So we should be done in less than. What time is it now? 9 o'clock. Yeah, we can try. After Jacqueline is done with this, and we play around a couple of times, random sentences, and then Yen, you can pick up the screen. We'll come up with something else, right? We'll try something else, or we'll just take this and play more with it.
Wait, don't you need the 1 after the adverb, verb, and PP?
No, because they aren't. There's only one of them.
Oh, I see.
In the sentence, yeah.
Okay, thank you.
Yeah. In fact, we can make this. Yeah, we don't have to mess around with this because we have to remember now, right? Suppose what if we had like 15 nouns? Do we have to remember N1, N2, and all the way? So you can think of ways in which we can make this. But slot grammars don't get complex. Never get complex. Much more complex than this. These are slot grammars. Even the grammars that are used by Alexa and Siri and Siri maybe not so much. But initially, right, many of these grammars you can get away with just slot grammars because you can say these are the things that the system is going to expect, right? And these are the variations in those words, right? So just train the system on lots and lots of those variations, and then it'll just look for those patterns. That's called a slot grammar. And slot grammars are really easy to recognize, right? Whether it's speech or generate, also it's really easy to generate the slot grammars. But they don't get complex, right? So once you get past a certain level of complexity in grammars, then you have long range dependencies, right? So this verb count has to agree with that noun count and all those crazy things, right? You can't even model those with a finite state machine. Do you need more complex grammars for that? And you go from and this is a study of grammars. Is an entirely huge field by itself, right? So that's linguistics, and so we slot grammars, template grammars, very simple, and that's all we do. And that's it, right? In fact, tomorrow you can go and work in a, you can design your own call center, right? You can basically, rent a bunch of machines on Amazon, come up with a really sophisticated slot grammar, and say, you can turn that slot grammar into a call center, because the call centers basically they field template calls, right? Most of the time, call centers let's say you can set up a filter and say, 95% of your calls I can just route to my slot grammar automaton, right? 5% we need humans, and those can go to real human beings, but 95% can just fielded by my automaton, right? So you can just write a very simple slot grammar and you're done. And well, it doesn't have to be. It can be so simple, but you have to have these tweaks, and we're going to make a couple of modifications right now. Okay, so let's go in your main. You got all the strings. Print them out too. So you can say on the next line, another blank line there. Yeah, and you say, see out, your lucky sentence of the day is, right? Your lucky sentence of the day is, and then end line, and the next line you can print the sentence that we got. Right? Yeah, new line, and on the next line you can say, see out all those guys with spaces after them. No, if you want to use a slash in, the slash in has to go within quotes. You can right there. You can say, see, that's 4 characters, but actually it's more expensive to type than endl, right? Because endl is all same case, but in order to get quote, you have to shift and that. So that's actually 6 characters altogether. I don't know. Yeah, and they're all far apart, and you got to search for them. Endl is easier. Yeah. Oh no! Endl, and then next line. Yeah, let's try and so yeah. One of the things we can try and do is always try and make the program mirror what the user will also see in the end. That'll keep it easier for us, because we'll also, as we're writing the program, we'll also get a rough idea of what the user is going to see. All right. So art1 space and then add one. Yeah, Jacqueline's got the hard job of the day. All right. So you need the less than operator, the left shift operator between those guys. I guess you're going to copy and paste that later.
And Professor, don't we need a space between those?
Yeah. I think Jacqueline is gearing up to copy and paste one bunch of things at the end between all of those.
Yeah, it helps me to just go through them fast and then edit after.
Oh, actually, I thought you were going to do, hey, Jacqueline, stop right there. So you know where you did that? Say, left shift, you've done that, right? And then say, right where your cursor is, open your quote, open double quotes. Yeah, space, close double quote. And then, no, you need one more left shift after that, right? Because the adverb is going to come next.
Oh,
so,
yeah.
Okay. Right, now you can copy that and then do a kind of command V or control V between all of those guys. Yeah, I can break it up and take it to the next line. It's it's starting to get too long. After the preposition, maybe, go on to the next line. Now you can indent it further. No, you can continue with the same cout. You just indent the left shift, line up the left shift with the previous left shift, and then we'll know when we read it that, is it the default indentation provided by VS Code? When you hit tab, is that where it went?
What do you mean?
When you hit tab in front of, under the cout, get under the cout. Yeah, right there, right where your mouse is right there. Yeah, hit tab one more time. Oh, it actually does tab.
Yeah.
Oh, I thought it calculated the indentation, and it thought that a continuing cout line, the operators need to be aligned, right? Maybe sometimes Xcode does that thing, right? So Xcode or VS Code 2, they determine the optimal placement, and I thought they actually did that. It's just inserting a tab, right?
They do sometimes.
Oh, it does? I see.
Yeah, I think it, if everything is correct,
It'll do it.
Okay. It will do.
All right, so backspace now. All right, so R2 adjective 2
And I
Something's
think you
lacking.
forgot a semicolon after end line in the end too.
Oh, yeah.
Yeah, and also I think there's some spacing issue there. Adjective 1 and adjective 2 aren't lined up properly somehow.
Should I do?
Adjective 2. Oh, no, you got an extra space after adjective 2, before adjective 2.
No, so it will
ADJ2.
let you go through the spaces.
No, that looks okay. Under ADJ2, you see
Yeah.
how ADJ1 and ADJ2 are.
Oh, I see.
Right, and then you need a new line at the very end, I think, of that. After N2, you need, yeah, new line. And I think return 0 after that should be fine. Yeah, enter, and then, yeah, return 0. Now we just need to flesh out those functions. Now, before we do that, a semicolon, and put a space, blank line after the cout. Yeah, one more. Get rid of the blank line after return. All right, now here, before we go to flesh out those functions, let's do something interesting, right? So we pick the adverb, right? We pick the adverb. No, what are the two things that we pick the article, right? So the article a and the and so on. So we pick the article, but the article always precedes something else, right? What are articles? Art 1 precedes adjective 1 and noun 1, right? Yeah, no. So here's what we'll do, right? So when we get an article, let's get the article after we get the adjective and the noun, right? So let's get the adjective and the noun, and then get the article depending on the two that we've got before. So we just need to go back to the top, not to the very top, a few lines up. Yeah, okay, they're here. So you see how you say a string art 1, right? Triple click on the line, triple click on the line. No, 3 clicks, three. All right, now hit Control X or Command X. Control X. No, Control X should do. No, Command X.
Sorry, I'm on a Mac.
Oh, Command X should do. And triple click in Command X.
I just did.
It didn't?
No, I just did.
Oh, it didn't do it. I know, but it didn't do it on screen. Cut the line.
It's cut.
Are you in Emacs mode or something? Even then, it's a.
No, it's cut. It's
oh, it is
not there.
cut. I'm
Yeah.
so sorry. I'm not even looking at the words. I'm looking at the gray band, and I think, why is Command X not working? Because the gray band is still there. Damn.
I just don't know where to put it.
All right. After the noun, after you got the adjective and the noun, and then you can put it there. Oh, now you're gonna get a, All right. So here, now get rid of the blank line. Right now, get the other article 2, right? Triple click on line 25. Triple click, Command X. Now, right, Command X. All right. Now, don't just hit your down arrow and to go down 2 steps. Down arrow 2 times. You don't want to go to the right. Now hit Command V. Okay, now it's all, now you didn't have to push it in and push it out and so on because it pasted at column 0. Previously, it was out there because you pasted it there. Remember? And then you have to re-indent it. Okay, cool. All right, now we know at the time we call give me an article, we already know what the adjective and noun were. Yes? So we can pass those 2 as parameters and say, give me an appropriate article, right? If my noun was an apple, I don't want a, I want an, right? Like that. So you can say article, get random article is going to take 2 parameters, and you're going to pass it up here on line 21, inside of the parentheses. You're going to pass it the first parameter, which is going to be your adjective 1, comma, and then noun 1, right? So those are the 2 parameters you're going to give, pass the get article, and my article has to depend on these 2 guys, right? And you can do the same thing for the next one too. So strictly speaking, it's it's not completely slot filled at this point. We're injecting some rules, but it's okay. We're just having fun here. Okay, now let's change the signature of the functions. Also, yeah, get random article. So it needs to take string adj and string noun, string adj and string noun, right? Or adjective and noun. You can call it whatever you want. Now let's do one more thing here. You see how we have the main at the top and we have all the functions below it. But in main, we're calling all these functions, right? So when the compiler, whose responsibility it is to take your main program and convert it into binary machine instructions, sees main invoking all those other functions, it hasn't yet encountered those functions. And so it has no basis for knowing whether main is calling them correctly or not. Like, for example, your get random adjective takes 2 parameters. Let's say your main called it with no parameters. How would the compiler know? So the compiler has no way of warning you that. So there's 2 ways in which we can solve it. And one way is to just take main and put it at the very end. So, the invocations of the functions are not even visible to the compiler until it has had a chance to look at all the functions. So that's one way of doing it. It's not a very scalable way, and it's not a good way. So it'll do for now. We'll do it that way. The other way is to pre-announce to the compiler, saying, all right, I have all these functions, and they're going to be declared by, Mr. or Miss XYZ in some country somewhere. They'll send me the compiled versions later, but I know that these are the ways in which these functions can be called. These are the signatures of those functions, right? This function, when it's called, needs 2 parameters. It returns a double value. And all those, that's the API. The way in which you interface with the program, that's the API. Right? The application programming interface, API. So as long as you know the API, you don't need to know the guts of the program, right? That could be outsourced to some country out there. So someone else can do that thing and give it to us. And so many miles away, we don't need to care, right? That's the beauty of it, because we have the API, and that's a contract. We sign off on the contract saying, that's what you're going to do for me. That's fine. It's got to follow this thing. And as long as you're okay with that, now that API is that thing that has been agreed upon is now stored between the 2 of us, and we use the same API. And where do we store that API? Can someone take a guess? Where do we store that contract which says how we are going to call the various functions?
Is it in a library?
Right. So it is stored in our header files. So you remember now that in our programs at the very top, we say hash include this, hash include that, hash include vector, and so on. Right? The .h files are header files that basically pre-announce to the compiler, right? This person is going to use the vector class. Well, strictly speaking, in this case, it's not like that, because the vector class is a template class and all the code has to be in the header file, but it doesn't have to be like that, right? So in our case, for example, or traditionally in the ancient days of C and so on, right? The header files only used to contain introductions to the various functions. The functions themselves, they don't live in the header files. They live somewhere, right? You can buy the header file. I can say, I'm going to use this header file, but the actual functions I'm going to buy from Borland, or I'm going to buy from Microsoft, or I'm going to buy from, so you can buy the actual functions from different people, but they all behave in the same place, in the same way. Like, you want to buy a phone, you have the API of the phone, lets you make phone calls, internet connectivity, and so on. But you can buy the phone itself from different people. And you don't go to Google or Apple and tell them, oh, you got to make the phone this particular way. That's the only way I like it. They give you some sort of customization options, like APIs do, right? But they don't give you all of the options, right? So you can't say, you can't dictate every single way. So you say, and besides, you don't want to do that, right? If you want to go and dictate to Microsoft or Apple, this is how you should build your device, you're wasting your time, right? Because they've spent enormous number of hours researching this, and they've come up with incredible ways of doing these things, and you're going to waste your time thinking about how a phone should be designed rather than about an interesting problem that you've got your mind, So it works in our favor that we can basically say, here's the API, right? So you guys go ahead and do it as you best see fit, because you have lots of experience doing that particular thing for eons, right? Go and do it, and then give it to me. I don't care how you do it, but I know that you're going to do it in the best possible way, right? Because if I'm going to outsource something, right? I'm not interested in outsourcing it to some random party who are going to, stick to the API, who will do it, but it's going to be done in a very bad way behind the scenes, right? Like, I don't know, sometimes when I use the Canvas, for example, right? You must have felt it, right? So click on the Canvas modules, and it's so slow to load sometimes. Whereas, go to the exactly same modules that I hosted on nonlinear media, right? So loads of modules, right? And you see how fast they are. That's because I basically took it and stripped out all the JavaScript, because the modules in Canvas are so heavy and they have so much JavaScript built into them to do things that are insanely unlikely, right? Only 0.0001% of the users will probably do some crazy JavaScript action on that page, right? And there is like 3,000 line function that is loaded by every single user of Canvas, right? Because that, you see what I'm saying? So it's possible to write things. So even if you're going to outsource things, you're going to pick among various bidders who is going to do the best job for you, who's going to consume the least resources, who's going to burn the least carbon, right? So you're not going to give it to a quadratic algorithm because they just, the result is not due until, next month. So, right? So you're going to do that. And I don't know where we're going with that. But yes, header files, right? So we just say that's our header file. So get the header file, and as long as this is the header file you're going to use and I'm going to use, right? If you don't stick to that contract, the compiler will, is the overarching entity here, right? As long as we both promise to use the header file, which we say is immutable, read only, right? Your code will not compile if you don't stick to the header file. My code will not compile. So we're both forced to stick to a unanimous third party. So that way we can also make it simpler and easier to collaborate, because we're saying you don't have to listen to me, right? I'm not the paying client, right? Or I don't have to listen to you because I'm dependent on your services. We both have to listen to this third party, which we both agree to listen to, right? This compiler is going to tell us whether something that we agreed to is okay with us or not. Does that make sense? So that is, a very long-winded answer to someone brought up, we are moving the functions up. So for now, let's move this function up and all the functions up and move main right to the bottom. But it will be cool if one of you can try to take these functions and move them to a completely different file altogether. Move them to a completely different file called generators, right? These are generator functions, and then have a header file, which basically just declares the functions, and then include the header file. So it's exactly the same logic, and the only thing that's different is the way in which the project is being put together. That's all, right? It's exactly the same thing, and it helps to know multiple ways in which you can do the same thing. It's not that you have to know every single way, but I think it's just good to know that there are different ways of getting to the same thing, and that way I think we are able to proceed with less care, not less care, less concern. Right, because when every time we embark on a task, let's say CS2A, right? So you enroll in CS2A, CS2C is more like it, right? CS2C, many students enroll in CS2C, and I think they don't end up doing a good job, even though they're able to, right? I can tell. I look at the code that they submitted for the first couple of quests at least, right? I look at it in detail and tell, well, these guys can absolutely kill it. Right, but then they peter out after a while, and I try and think of reasons, and I think what is happening is that somehow we try and we convince ourselves, we think that the tasks downstream are going to be insurmountable, right? So yeah, I think we just say that there's only one path to the end, and I'm stuck here, and I can never reach there, so why even bother? I basically give up, right? So if quest 4 is so hard, and I can see in the forums that people have been sweating it out on quest number 6 and 7 and 8, right? I'm never going to get through it in time. So and basically just and I think that is the wrong attitude, because we are mentally consigning ourselves to saying this is the only way to success. I got to do the quests, or so I think we got around that somehow by reassuring all students, including CS2A, CS2B, CS2C, that if you just want to pass, you got to pass. If you just have to do 6 quests, right? 6 quests, get to the end of the 6 quests, which is really easy, right? With help from us and STEM Center and the STEM Center, 6 quests is easy, right? If you get to the 6th quest, you will pass that particular section, whether it's 2A, 2B, or 2C. I think the difficulty levels are such that, and the topics covered are such that, and after the 6th quest, you can shoot for the grade, and you won't be stressed out, right? So you won't be stressed out, and I think then people will keep progressing, because then you're not doing it for the grade, right? Because if you're doing it for the grade, and as soon as the grade becomes less than 10% possible, right? 10% possible, your threshold kicks in and say it's not worth pursuing anymore. So you start looking at, hey, maybe I should that paper that I've always wanted to do in ceramics, right? Maybe this is the time to do it. So and that will take and you could branch off at the wrong time, and that's why I think now saying that you're going to pass, right? If you do quest 6, you're passed anyway, so you don't care. Now, then you can just proceed at your own pace. Then everything you do, you're just doing for your own sake. You're not doing for the course. You're not doing for the grade. You're saying, I want to do it because it's fun, right? Yeah, I don't care. I've already passed the course, right? I'm just doing it for fun, right? So you can turn out all the party invitations. You can say, I'm not going on my date. I'm just going to sit down and, keep question all day, all night. So, right. So you can, because you're doing it for fun. You're doing it for yourself, not for someone else. And the sooner you get to it, the better. And that's why I think I would love, ideally, I would love to make quest number 2 the passing quest, right? If I could say that you only need to get to quest number 3 and then you pass, right? And then everything else you do for your own sake, that would be great, but so the smallest number I've been able to get it to is 6. I think if you get to 6, right? Eddie is not here today, right? And he's in a different time zone, and and he has a couple of questions, and nobody's answered those questions in the forums. And I'm waiting for someone else to answer those questions. Please do. But he should know, right? Quest number 6. Please pass the information on to him if you're in touch, right? So quest number 6, you get to it, you pass the course, and then you don't. And the end of the course doesn't mean you can't quest anymore, right? You can quest for as long as you want, right? They're just on a very cheap compute server on Amazon, right? I don't have any reason right now to shut it off at all. So you can just quest forever. As long as you want. So you don't have to say by the end of final week 12 I got to finish this, right? If you're doing it for yourself, you can do it whenever you want. Okay, all right. So all right, we're coming back to this issue. Are we good now? So we got to pick a random article, and we're passing these 2 parameters. Let's do some easy ones first, and then come back to this random article, because the random article is going to depend on the 2 parameters that we pass it, right? Because you've got to look at the adjective. If the adjective is empty, right? Then look at the noun, and got to get the first letter. Basically got to get the first letter. Okay, so let's do the first thing. Let's pick some adjectives, right? So say vector, string, vector, indent in.
I think you forgot the return type on all the functions.
Oh yes. Yeah, say string in front of all of the functions. Thank you, Chris. Was that Chris? I didn't see.
Yeah, it was.
All right. Okay. All right. So, yeah, string in front of. Yeah, declare all of the functions. Did I say something like Alexa before? Because it just picked up. It's a lot of grammar. Speaking of slot grammars, all I need to say is Alexa something, and then it'll say, "Hey, did you ask me? Hey, master, did you call me?" Well, right now I called it 2 times and it didn't say anything. Okay, so that's funny. Alexa. Okay. All right. Okay. All right, great. So yeah, vector indent in and say vector string, and say adjectives. And someone please at the same time Google and find some interesting adjectives, right? We're going to fill something some ourselves, right? So yeah, angle brackets. No, angle brackets are on the string. Angle brackets are on the string. Hey, Turkey has posted a link, I hope, to one of those lists. Thank you. Yeah, so angle string. Yeah, and say adjectives, right? Adjectives. Right? And then say equals. I think we can initialize a vector like this, right? If it's not the case, we'll find out very soon. Open curly, curly brace. Yeah, hit enter. And then at the end of the closing curly, hit a semicolon. So that we have the at the end. All right, at the end, yeah, hit a semicolon. So now we're going to flesh in the body, right? So go into the vector now. Let's put in a couple of interesting adjectives. Let's say start with some boring ones. Say tall, T-A-L-L. Everything has to be within quotes now. Oh, you can select the whole thing and hit quote 1 time. Is that? Oh, I see. Cool. All right. Tall. I don't know. Hey, guys, I'm not the only one. Okay, Turkey posted a link, so go to the link maybe. Right. Call out some adjectives to put in there.
There's abandoned.
Abandoned. Yeah. Angry, happy. Let's put in the basic emotions. Lovely. Sad, which you typed, right? I said sad, and you said yeah, happy, sad.
Afraid.
Afraid. Hey, afraid, is that a, oh no, let's not do afraid, okay? Because afraid, yeah, is more often used as a non-adjective, I think, as a state of being, right? I am afraid, rather than I'm an afraid cat. Okay. Anything else people can think? Is that, what is the link that Turkey posted? Can someone click on the link and see what if there's an interesting stuff in there?
Yeah,
I'm reading
it's,
them right now.
It's a bunch of TXT files, one of them with adjectives and the
Oh,
other
I
one
see.
with nouns.
Okay, let's do nouns. All right, so stop with messy, right? And then let's do nouns now. Yeah, and then do something like that for nouns. No, you already have. Yeah, you just have vector string nouns equals. Oh, let's complete the adjective function, right? So get to I'm sorry, Jacqueline, right? So yeah, the previous function, let's complete it, right? Yeah, enter after the semicolon, right? And now just say return adjectives of, return adjectives, square bracket, and a square bracket, right? This is the construct we use very often, right? So it's going to say adjectives dot size, rand open close, rand open close, rand R-A-N-D, open close, yeah, space percent space percent space. No, the open close is there. You know, that's it. Open close. That's it. No parameters to an end, right? So yeah, there you go. After the closing parentheses, space percent space. Now we're going to take this big random number divided by the size of the vector and get a number between 0 and the size of the vector. Yes. So we're going to say adjectives dot size. Adjectives dot size. You can actually double click and paste too. Yeah. Dot size. And then open close parentheses. Right, and then you can put a semicolon at the very end. Right, that's all. Right, it's just 2 lines. So we got a vector. Right, this line will basically generate a random number from 0 until the size of the vector. Right, if the size, if there's 10 elements in the vector, it'll divide by 10 and take the remainder. Right, so it's got to be 0 to 9. So it'll return a number between 0. That percent thing, that whole thing there is basically a random number between 0 and 9, or 0 and the size of the vector. And that is going to index into the vector, pick a random one and give it to you. That's it, right? So, and we just need the exact same structure in all of our functions, right? So let's do nouns now. Let's pick the nouns from the link that one of the text files that Turkey shared. I believe it was. Oh, Mark, we won't do regular expressions, right? Did you type in a regex for finding out if which article should be used?
It's a regex actually to take a list of words and then slap quotes around them with commas in between.
Oh, I see. Wow.
So you can
take that works in VS Code. Is that can that be a VS Code macro?
This is actually for use in a find in place.
Yeah. I think she was using a feature that was built into VS Code. Oh, but it doesn't do multiple. Yeah, that'll be cool, right? That'll be cool. If you had an entire line of words and you just highlight the entire line and then hit the quote, and then it broke up on the commas and individually tokenized the words, right? That'll be cool.
Yeah, well, I was just looking at Turkey's list and it's like, I don't really feel like putting quotes around each of those.
Oh, so you can do that in the editor though. You can just do that in the editor. You can just do, replace the commas. I think in the editor, yeah, you can go to the editor. Well, maybe he has 1,000 words in there. We don't want 1,000 words. How many words do you have in that list? I haven't seen the list.
It's a long list.
It's a lot.
All right. Just copy some random section, maybe 5.
I thought I wanted to do the if stream, so we could just put it all in one.
I think so. Yeah. Actually, this will be really cool, Turkey. If you can take this program, which we won't do with files, right? We won't do this with files. But if you can adapt this program to read each one of those components from different files. Or even put a single file, tagged separate suitably, right? That will give you a much richer sentence, right? And you can even expand on the grammar. You can make it, the template, right? So you can do, that'll be really cool. That's a nice little project, right? And then, every day, instead of, as soon as you run the program, it shouldn't print the sentence immediately. It should like an 8-ball, right? It should slowly fade into view, right? If you had the Unreal Engine or something like that, you can do it like that. But even here, you can say, you can print a message. that says, your message is being generated, right? And you can sleep for 5 seconds or something like that, right? And then pick the sentence and slowly fade it into view, or, or print it one character at a time, right? Build up some suspense, and that'll be really cool. Maybe it'll be a viral game. People will just share it, right? Generate your sentence of the day. Better than fortune cookies. Fortune cookies, after a while, you get the same thing after. I must have got, you're going to be a really rich man like 100,000 times now, right? Right? But yeah, I'm just kidding. But after a while, fortune cookies. I think you're getting it all. They're getting it all from the same vendor, right? Eventually, they all consolidate. They buy each other. This is one big company, and they start economizing. They say, oh, what we're doing? 1,000 fortune cookies. This is costing us a lot of money, right? So we'll just do one little cookie and only so much ink, right? Right? And they print it on all of them, right? Because you got the clients now. You can do whatever you want. Okay. All right. So so now, yeah, this is, I'm putting a bunch of nouns there. I know. 10 nouns. The cool thing with vectors, right? So that's the thing I like with vectors too. With arrays, you got to do a whole lot messier, right? It's because with arrays, you got to calculate how many elements there are. Because the arrays, you only get a pointer, right? And then you got to say, oh, how many elements are there? And it's really messy. With vectors, you can just say dot size, and it's even the dot size is not even. See, when you have a collection of items and you call dot size on the item, say, tell me how many items you have. It could be an expensive call, or it could be a cheap call, right? If it is an expensive call, if the call say, how many elements do you have? Oh, wait, I got to go and do a census now. I got to go and count 1, 2, 3, 4. Then it's really bad, right? So dot size is an expensive operation. It needs to go, and your time is now dependent. The more elements you have, the more time it's going to take to tell you how big it is. Right, so vector and these things are actually intelligent. That's why I like vector, right? So it doesn't do this linear thing and go and count all these items. It actually maintains this thing as part of the class, of the object. That vector thing that you're using, inside of it, it has is a number, is a variable, is an integer type or a long type, right? It's right there. And so when I say what is your size, it doesn't go and count. It'll tell me what the number is, bam, like that. So I get it instantly. Right, and those are really cool things to have. The same thing happens in an array, but the syntax for it is more ugly, right? So this way it's cooler. Hey, thank you, Jacqueline. So she's been filling in a lot of these things. All right, adverb. Yeah, and after you do the verb and the preposition, we'll now tackle that adjective thing, right? And also the one thing we want to do is for adjective, let's also include the blank string, right? Maybe there's no adjective. And adverb too, right? So those can also be options. So it could be blank string. Yeah. Adverb, broodingly was one. Okay, let's start with broodingly, and then happily, broodingly, and then happily, angrily. I don't know. All right, so we got 4, but chime in, right? More. Jokingly.
Firmly.
Slowly.
Carefully.
We'll start with this anyway, right? Yeah, sorry. Someone else had some words. Someone said something? Careful.
Yeah, careful.
Okay, cool. All right, let's get some random verbs and prepositions, and then we'll do the articles, and we're ready to go. After that, we're ready to go. We just run the program. What time is it? Yeah, it's 9:30. So we should be done by 9:40, and then we can run the program a couple of times. Yeah, sure, Hao-Yan, that's fine. You don't have to ask me, right? You just switch off the thing. Oh, I see. You're not going next. Yan is Yan, yeah, you were going next, right? Well, maybe Yan, you just go next class. Yeah, is that okay? On Tuesday. Which means on Tuesday you can do any program, right? It doesn't have to be on a particular topic. Any topic that we've covered in CS2A so far, from beginning to do all of that. Float, yeah, float. Fly, float and fly. Oh, I think everything should be in the same tense. Yeah. All right. So let's keep everything in the past tense. Yeah. So ran, danced, walked, drew, and so on. Yeah. Because otherwise it'll get really messy. I think we got to incorporate more rules. So, is that it? Yeah. Okay. All right. Let's do some prepositions on, under, over. Is that it? Let me start with these three. All right, let's go to the adjectives now. All right, so the article. Now here's the interesting thing, okay, right at the top. Now we want to return either a or an or the, right? One of those three. So in a comment, no, you don't have to copy and paste there. Unfortunately, we won't be using any of that, right? So for now, yeah, get rid of that. And in a comment at the top, say return a, an, or the, depending on the first letter that follows. A, an, a, comma, a can. Actually say a within quotes. I think that's easier because a looks like part of the sentence now. So say a within quotes. Return a within quotes. The first, a within quotes, yeah. And then comma after that, comma after the quotes. Yeah. And then an within quotes, yeah, an, an, just not and, and, or, yeah. And then finally, no, or is good, No, or we don't want to return or. The should be within quotes, the. Is that good enough? I think so, yeah. THE and then space after the quote, depending on letter that follows. Okay. All right. So let's first find the letter that follows. Okay. Indent the comment in also because it's after the brace. And then I think you're missing a space after the. Wow, that's okay. You're missing a space other places too. All right. So now, in fact, what would be better is take the comment and put it above the function, right? Because inside the function, let's keep it clean, right? Take the function, take the comment, and triple click on the line. Yeah, cut it and put it above the line. Yeah. And attach it to the function. All right. So now what we want to do is indent in and say determine first letter or find first letter. Comment. Yeah, find first letter. All right. Okay. Now you say char. Here we're doing all these different data types here. Okay, really good practice. Okay, char space letter 1 or first letter, whatever you want to call it, right? So some variable, letter 1 equals space equals find first letter. So here, okay, Turkey, you wanted to write a recursive function last class. Okay, so we're going to write a recursive function here, but you never write after this. Don't write a recursive function on your own. Okay, save it until CS2B. Even Fibonacci and all. Don't recursion. It has lots and lots of crazy things. All right. Find first letter, and find first letter needs to be passed 2 parameters. Okay, ADJ comma noun. Right, ADJ comma noun. Okay. Now, depending on the ADJ and noun, it's going to return a first letter. That's all. Okay, that's all it's going to do. Now, next line on the next line, a semicolon there. You need a semicolon to end that. Right. Remember now we have to write that find first letter function. It hasn't been written yet. Okay. So if letter equals, I think it's off by 1 character, the indentation. Yeah. And then you need a open parentheses after the if or before the letter. No. That's okay. After the before the L open parentheses. Yeah. If open parentheses there. No, not the whole thing, just before the L. Okay.
Oh.
Yeah. Okay. And a space. And letter 1. Sorry, letter 1. You can say if letter 1. Honestly, it would be better if you didn't call it letter 1 and call it just L, right? Or you just say C. You'll know very soon why C, right? Just say C. Right? Just say C. Char C equals. Right? If C equals, if C space double equals A. space double equals A, or open quote, open within single quotes, within single quotes. No, just the A within single quotes, not C, right? Within just the A within single quotes, yeah. Within single quotes. Yeah, most of the time it should work. No, within single quotes, not single parentheses. Single quotes.
Oh,
Yeah. Not double quotes, single. One. Because single means it's a letter, right? It's an ASCII value. Double means it's a string. So we
does
should.
it,
That's
does
correct.
it run, does it not run if it's double quotes?
It will not compile because the compiler will say, hey, you're trying to compare a character to a string, right? And in fact, it's not even a string, it's a pointer, because in C++ and C, anything within double quotes is not natively a string. It's not even a string type. It's a string type, the compiler will basically barf altogether, right? It's trying to an object to a character, it won't even compile, right? But if it's treating it as a pointer, it might actually warn you, saying, hey, you got a character that's only 1 byte. And on the right, you have a pointer that's 4 bytes. You're comparing. It's the same kind of warning you'll get later on in C++, right? And when you submit your quests, saying, "Hey, comparing us, unsigned with signed type and things like that." Okay, so that kind of warning you'll get. All right, C double equals A space, and then vertical bar, 2 vertical bars, or that's vertical bar, 2 vertical bars, shift. Yeah, or C double equals E. No, you got to say C double equals. Yeah. See, here's the interesting thing, right? So remember how you actually typed the thing without the C double equals here, right? But you actually knew, or I was telling you, right? You typed that. Now, unless you are actually coding it, right? If you read it in a book, you'll know, I shouldn't do it, right? But unless you are actually coding it, you would never actually run into that situation. And that's why I think it's the same as math proofs and all, right? So you have to work it out. A lot of people in CS2A enroll in CS2A thinking that I can master programming by reading all the books, right? They read the material, look at lots of example programs too. And unfortunately, you can even pass many of the courses in places which test you on fragments given to you. And you got to, identify issues there or say it's right or what it does and so on and so forth. You can actually pass and say, I know C++. Absolutely not, right? So 90% of it is, this kind of thing. You'll never run into this. And see, that's why it's so important to all of you, right? And so I'm so happy that all of you had a chance to come on screen and code, because that kind of thing you'll never run into. All right, so let's do that for all of the vowels. That is actually, Peter. Yeah, let's do it for all of the vowels. You want a cookie? But right, do it for all of the vowels. I'll give cookie to Peter. Hey, no, not inside. Go.
Hey, just conceptually, can you not put like a parentheses after the double equals and put?
No, you can. So what Jacqueline's got here is a condition where if C matches any of those, or this or that or that or that or that, it is true. The whole thing is true if any one of those is true. So that's the condition. Is that your question? Your question was, can I just put the parentheses after the very first one? Is that what you asked, Mark?
Well, I mean, if you pop up in chat, you'll see what I'm formally trying to ask. It's kind of hard to describe in words.
Okay, all right. Oh, you need a parenthesis. Oh, I see. I think Mark is saying you need a parenthesis before a semicolon, right? And get rid of the semicolon altogether, right? So yeah, put it.
No. That. But I think what he's asking is, can you basically put parentheses around this? So it'd be like.
Yeah, can you just in the next
line? Oh, I
see.
each one of them inside a parenthesis of their own. Each one of the comparisons, C equals A within parentheses, C equals E within parentheses, each one of them in their own sets of parentheses. Is that what you're saying?
He wants to put all the vowels in one parentheses as like C equals A or E or I or
Yeah, that's
O.
what I said.
Oh.
That's not possible. And I said
okay.
that is the reason. So that's what Jacqueline started doing. Jacqueline, isn't that what you started to do?
Is there like an in function? Like,
Yeah, there is. It's all more expensive than this. That's why we didn't go into it.
okay.
Yeah. And there is an in. You can have a collection. You can have a
Yeah.
collection of items and say, is my object in that item, in that collection? And then depending on the nature of the collection, your in could be, I don't know, different kinds of complexity, right? If it's a vector, it has to do a linear search. If it's a sorted vector, it could do a binary search, right? And you're going to implement a binary search in 2 weeks from now, right? So you could do a binary search, and you can tell you that whether the item is there or not in logarithmic time, which is really, really fast, but still not as fast as bam, like that, right? It's logarithmic time, or maybe it's in a I don't know, different kinds of structures, different search times, right? So that's why we didn't do it, right? You will get more than your fill of trying to check for elements in later requests. So let's not go down that road now.
This is still the slowest option though, right?
It is definitely an option.
Okay.
No, you can't do that with vectors. Is vectors, I don't know if vector supports an in option.
Okay.
But you can look it up. You can just go to a tab in Google and say vector C++ vector API. Just open a tab. So that's what we do all the time, right? So you open a tab in a browser. Get in some kind of browser window, right? And then you can say vector C++, right? And then it'll give you the API. It'll basically give you the header file, the API. In fact, it's not the header file. It'll give you the header file distilled to the API, because now these modern template classes don't only have the declarations, right? They also have the implementation, like I said before. Now, if you have the entire thing there and say, here's the API, look at it, most programmers will say, it's not worth my time to scroll through and find out and search, right? So these places like CPP data, preference and all those websites, or even MSDN, the library thing, right? They will not give you the entire thing. They'll just give you the header line alone and say, well, it has the dot size option, right? And this is how you call it, right? And if you click on it, you can see the whole detail. You can see how size is implemented and everything, right? So do you want to try that, Jacqueline? Do you want to go? Do you want to try it? Or you remember, you believe me?
I searched, I believe you. I searched because I have a bunch of tabs open and I don't want to share them all.
Yeah, let's not do it. All right. So, but just for the record, you should never believe everything I say, right? No matter, just like I said the same thing to Elizabeth last time, right? So you got to check this out in your own time and make sure that you can go to the vector. But I think there is no in method for vector, right? There is an in method for some other structures, but not maybe some other languages, right? So close the parentheses after the U quote, right? Close quote, right? Enter. Yeah, tab in. You say, now if it begins with a vowel, I want to return an, right? Or the. The also works, right? Because the can be pronounced as the or the. Yeah. So let's say if it begins with a vowel, I'm going to return either an or the with 50% likelihood. 50%. So you say return question mark, written question mark. These are all these interesting constructs, right? So you can actually copy and paste return space after the return say space, right? And within parentheses say rand %2 equals 0 question mark. Okay. So here what we're doing is So no, don't have the question mark there. I'm so sorry. All right, get rid of the question mark in light gray so I couldn't see it. Okay, and have the rand open quote, open quote, and before the rand have a parentheses, right? That expression, we're evaluating that expression. Before the R, open the parentheses. Yeah. Okay, rand, and then say percent instead of the an, instead of the an, instead of the a. No, right there is fine. Rand. Every time you call rand, it's just no parameters. Just say, give me a random number. Okay, rand. Say percent. Hit the percent sign. That's all. That's all. No, that's all. He's begging.
Talking to Peter.
Yeah. Let me show you. Where's he going? Oh, there it is. Well, anyway, so you'll. All right. Oh, I'm sorry. You didn't change the and within quotes to a. Get rid of the and say 2. Rand %2. 2. And then double equals space 0 and then space question mark. Okay. Now what we're doing is calculate that expression. Is it equal to 0 or not? Right now we know that every number is 50% divisible by 2. Yes. Half the numbers are even, half them. So we know that if it's divisible by 2, it's true half the time, false half the time. So we actually have a distribution where you have a coin toss right there modeled. Okay, so now you can say if it is an even number, remainder 0, then return THE, right? So say THE within quotes, question mark, THE within quotes, and then after the quotes say space colon. Yes, colon, and then say what is it? And within quotes, right? And then after the thing, close. I think you have to close the parentheses too, right? Okay, so hit enter. So now 50% of the time, well, no, actually, so we've handled the case where it starts with a vowel, right? Now we want to handle the case when it doesn't start with a vowel. We know when it doesn't start with a vowel, you got to return either A or D, right? It works in both cases, right? So you got to say again, copy that entire line, triple click on 19, and triple click on line 19. Yeah, and then after the if statement, paste it again. Paste it again and indent it properly. Yeah, I paste it, Command V, right? Indent it all the way back. Under the if, right? And now instead of and, return A. Right, because it starts with a consonant, you want to return A. Now there is obviously scope for some refactoring here because D is being returned in both cases. You can do some different if structures so that D is being returned. So that you can play with yourself. Now you can close it. You can close this function. It's all done except for find first letter. That's the only thing we need to. Is that it? Yeah. So we just need to implement find first letter and we're done, right? So go right on top after the namespace and hit return. Right, one more time. So we're going to return our final function, which is find first letter given an adjective and a noun. Right. So yeah. So it is as a char. It's going to return a char because it's being assigned to a char character. Right. So say char returns a char. Right. So say find underscore first underscore letter. Yeah. And then adjective comma noun. Yeah. All right. Oh, they're both strings. Sorry, they're both strings. Now here is the interesting recursive bit that, and it's a very interesting pattern. Okay, and that's why I wanted to. So go to the end of the string noun, open quote, and then open your body, the function body. Yeah. Okay. Enter. Yeah. Right there is fine. Now here's the interesting thing. Okay. So the first line is if adjective equals your null string, which is open quote I always get into the habit of if statements have to have a body with are you a Python programmer?
Yeah.
All right. Okay. So I just yeah. All right. So put an open parentheses before the adjective adj.
If
right. Yeah. Open parentheses and then adj equals so double equals. And then the empty string is basically two double quotes, right? Yeah. And then, close the parent empty string. You got an empty string there? A space, empty string. Yeah. Okay. Now on the next line, you don't even need the quote. You didn't need the braces, right? Because it's just going to be one line. It's a recursive call, right? So you say if your adjectives yeah, okay, so all right, good. All right, so if gee, I didn't think this through properly enough. What I wanted to do was if your adjective was null, then you call yourself saying on the noun instead of the adjective, right? So in that case, what we should do, I'm sorry, Turkey, we're not going to be able to do that recursive thing that I talked about before. Is that okay? Okay, get rid of that thing. So what we want to do is, no, not that. Get rid of the adjective equals, right? So just say first char first letter equals adjective. If char first letter equals letter equals. And then do the same ternary, was it ternary or tertiary? No, ternary operator that we had before, the question mark thing. Just copy that entire question mark thing and put it up there. Yeah, triple click and put it up there. Triple click and put it up there. And we indent it properly and we can fix it up.
Sorry, it's double click. It's not triple click.
Put it up there. Put it up there. Oh, you cut it out. You put it back. Yeah, and put the at the end of the equals. Yeah, put it there, and then we need to get rid of a lot of stuff there. What happened to? We don't need the return and all. We just need to part from rand onwards, right? We just need to part from rand onwards. Yeah. Okay. So what we want to do is instead of rand %2 equals 0, we're going to change the condition. We're going to say if adj dot length, right? If adj dot length equals 0, right? If adj dot length equals 0. If if adj dot, I think it's a string, right? So I must have a length. And length is I think we found out last class, length is a function you got to call with open parentheses and close parentheses, not a property. You got to say open close parentheses equals 0. Then you return the first character of noun, right? So you say, if the length of the adjective is 0, return nouns of 0, right? So you got first letter, right? So say, yeah, so turn the into noun square bracket 0. Right? Noun square bracket 0. Square bracket 0. Yeah.
You want me to like completely get rid of?
Yeah. And we can structure this whole thing in many different ways, and it's really cool, right? Or return the first character of adjective, right? First character of adjective. Colon there, colon. Yeah. No, not or. I'm sorry. I'm sorry. I said or. Just say colon. I think you got a colon, and then turn the an into the first letter of your adjective. In fact, you don't even need a separate function for this, right? You can just copy that whole line and put the whole line. Just put it there, and then we'll get away with this whole function, right? Because originally I wanted to do that function because I thought it would have a nice opportunity to demo that recursive thing pattern that I was thinking of. Oh no, adjective adj of 0, adj, and then the first character is not 1, 0. First character is 0, not 1. Yeah, 0. Now here, that's our first character, right? That's our first character, and we actually created a function for that and all, which really seems like overkill now. So let's delete the function, but we triple click the line, and we're going to move that line. Okay, so triple click and cut that line. We'll put it back in our function. Yeah, cut the line. We don't need the function anymore. Cut the line. Yeah, cut the line. And where do you find the first letter? Char c equals, right? Instead of calling no, up there. Char c equals. Yeah, you can just use
Sorry, where's
on the next line, and you go to the end of that line. Go to the end of line 21.
Oh, I see.
Okay, go to the end of line 21, and we'll just delete that line after we've done. Oh, that's fine. All right, paste it. There you go. All right, char, and you can say char c equals, right? Char c, you don't need first letter anymore. Okay, does that sound okay? Actual length equals 0. Get the first of the noun, otherwise the first of the adjective. Okay, the only and your first the comment there first is indented. The indentation is off for the first comment. Now, what happens if the noun is 0 characters long? If the noun is empty, right? So you got to be like super duper sure that the noun is not empty, right? Because now we're not even checking for the first letter of the noun, we're just returning the first letter of the noun, right? If the noun is empty, that could result in a serious error. Your program could crash and die. So right at the top of your program, where you declare the nouns, where do you declare the nouns? Random noun, get random noun, right? Put a comment there. Get random noun. No, I think it's up there. No, up. Get random noun. There. Line 35. right? Is put a comment there saying this vector should not be empty, right? This vector, some comment somewhere at the top of the function too is fine. All right. Note this vector should not be empty. For now.
So I have to actually leave in like 2 minutes.
What time is it now?
It's 9:55.
Oh, all right. Okay, we're actually in the class, and you guys are already 5 minutes beyond class. But well, this is the program. I bet if you compile it now, there should be no errors. Okay, so you should be able to run this, and it should also generate a program for you, a sentence for you. Everything should work. It's a working. You can get rid of it. That's a working program. I'm pretty sure. Compile it, no errors, right? I'm pretty sure I was doing a good syntax check when you were coding. All right, there. Oh, 5 hours. Okay, there you go. No matter how long you've been programming. All right, so I'll leave. These are simple errors. I can guarantee that these are really simple errors. If they are not simple errors, ask so in the forums, right? And I'll fix them immediately. Or you'll know, right? So I would really like it if someone can fix this program and share it, and also share a bunch of sentences, right? Share a bunch of interesting and cool sentences you've written, and also maybe Turkey can, oh, here's a bunch of files you can use with this program, right? Because once you've written the program, you can supply it any number of files. You can supply Turkey's pack, right? Or you can supply Mark's pack, right? You load the program with Turkey's pack, it'll shoot Star Wars sentences, right? So you can have these different kinds of programs, different kinds of packs that come with this program, different kinds of sentences. So all these cool things you can do. So how's that for a good little piece of program we wrote in class? Was it a good exercise? Yeah, was that useful to you, Jacqueline? So you actually coded on screen too, right? Yeah.
I'm
was
very.
It the first time? I vaguely remember you actually taking the screen the very first time. So.
I'm very I do a lot of copying and pasting, so it's good to break that habit.
Yeah. I'm actually glad you coded too. Hey, Yenyu, get ready. Okay, you're going to be coding next class. Someone please come up with an idea like this. Okay, something we can code in class, less than about 80 lines of code, right? And we can do it in class, and that'll be fun. And hopefully we can run it right today. Unfortunately, we can get a chance to run. But thank you so much for attending class today. And I'm actually happy that all of you are still here. So this is the last class of week 5. So I'll see you on Tuesday, and we'll review some of the existing classes and when you will code. Thank you all. Thank you all. And good luck and have a good weekend.
Professor, I had a question.
Yeah, sure. Hey, by the way, you guys can ask me any questions about quests, okay? Nothing to do with quests. All right. So, and I can't look at your quest code. I can't debug your quest code either. You can fight with the quest code and discuss your struggle in the forums. All right. People will absolutely help you, but you cannot ask me anything to do with your quests. And other than operational details, like I'm dropping into there and nothing's happening. That's fine. Or my score is not showing up. Even that is being answered, right? You should just feel free to ask anything, right? I'm pretty much turning off everything, not just in my class, right? Even in my life, I'm turning off all of my communication, one-on-one communication links, right? So that nobody can ever talk to me one-on-one at all. So because there's a lot of confusion that happens, right? Everything is open is much better. Unless it's something to do with my taxes or social security or health related stuff that I'm not supposed to. Right. So, yeah. So don't ask me any questions, and that's why I put in the syllabus too, right? Even for the last couple of quarters, because what I found especially here, right, is lots of people come not the past few quarters, right? A few quarters ago, I had a lot of students who would just come and ask me questions, and they didn't want to understand the topic. They just wanted the answer, and then that started getting more and more out of hand. And I said, well, you know what? It's the same, I'm giving the same answer to 5 different people, and you guys are not sharing with each other, obviously, right? So I said, and actually it worked out better. And then the students found that it was much better not to ask for personal help, right? Because when they come and ask for personal help, most of the time, many of the students are also used to tune out after the first 5 minutes, and I think many of the students got very anxious, trying to say, oh, am I following along with the explanation? Because if I'm not following along, maybe the professor is not going to teach anymore, explain this anymore. So they get anxious, and they basically out of step with you after the first 5 minutes, and didn't really work. Whereas if it's out in the open, then students also are not stressed, right? And they can just follow through the whole thing and see how as far as you can go until it starts getting complex and I can't understand. Then I can ask the forums, and everybody else will say, hey, I also got stuck at the same place, and here's what I found, right? That way it's much better.
Yeah. So my question is unrelated to the labs. But I had like a work conflict when it came to coming to the classes, so I missed a few classes, and I haven't gotten a chance to like code on screen. So I'd like to
Yeah,
do
yeah.
that
Oh, you
soon,
haven't.
possibly.
No, yeah. Why don't you? Yeah. You and you, both of you can code next class, right? But this is, we have until the end of the quarter. You'll have a lot of opportunities.
I just want to make sure I get the chance.
Don't worry. Yeah, you'll have. In fact, most of the time I'm just basically just forcing you guys. But now, fortunately, no, right? Because we're all friends, right? This is first week. People are not friends, and they're, now it's cool. Yeah. Thank you for volunteering to onward.
Okay.
I'll see you guys next class. Is that okay?
Bye.
All right. Thank you so much. I'm so happy to see you all, and your smiling faces makes my day. All right. I'll see you guys on this. Have a good weekend.